Hi, I'm Andrew with Nile. If you're dealing with complex NAC and fragmented policy models, I'm going to show you a simpler approach with identity based enforcement built directly into the network. This eliminates the need for overlays, VLANs, and separate enforcement tools. In this demo, we'll be showing embedded zero trust enforcement. Nile embeds device fingerprinting, identity-based microsegmentation, and native policy enforcement directly into the fabric's embedded software. This is so security isn't delivered as an overlay appliance, a bolt-on agent, or a separate policy stack. These capabilities come out of the box as part of the Nile NAS service, enabling customers to implement zero trust without using VLANs or implicit trust, or integrating an external segmentation firewall and NAC platform. The result is a secure by default foundation that aligns to zero trust principles, least privileged access, explicit access policy, and reduced lateral movement. From there, customers can enable business access by defining intent. To demonstrate this, we'll use the policy matrix to show two embedded innovations. First is default deny with a segment of one baseline to reduce lateral movement and blast radius. And second, a single unified policy model where we define least privilege intent once and the fabric enforces it consistently across wired and wireless for users, devices, and apps. The policy matrix is the simplest way to understand who can talk to what. It's organized by policy groups, which represents users, devices, or applications. These groups define the logical security boundaries we use in policy and can be based on identity. First, notice the baseline posture. Nothing is implicitly allowed. In zero trust terms, this is default deny. Second, endpoints don't get broad peer-to-peer access by default, even within the same policy group. Practically, this creates a segment of one baseline. Devices aren't placed into a flat trust zone simply because they share the same enterprise LAN. That combination is what reduces east-west movement and limits blast radius. Whether traffic is within a group or between groups, it requires an explicit policy decision. Now I'll create a new policy between the finance user group and the internet application group so you can see how Nile expresses least privilege and what the embedded enforcement engine can enforce. First is the policy name and description. Next, we identify the source and destination for this policy. Since this policy is being created directly from the matrix, the source and destination are pre-populated with the respective policy groups. Note the finance policy group is identity-based, driven by the user's IDP group membership and device context. The destination on the right is the internet policy group, which is the enterprise's RFC 1918 address space. The next step is the action. Here we want to allow traffic explicitly. For any allow or forward action, a service profile must be specified. This is where least privilege becomes explicit. Instead of permitting any protocol and any port, we allow only the specific protocols and ports required. For example, HTTPS to the internet and nothing else. Now we review the final policy and then apply it. You can see it immediately reflected in the matrix as an allowed relationship. From this point forward, the fabric will allow flows that match this intent and deny anything else. All of this is embedded in the operating system. No complex overlays or NAC integration or internal segmentation firewalls are required. Because enforcement is embedded in the fabric, we also get verifiable outcomes. Policy logs can be viewed with different filters. Here's the policy log records associated with the wireless user John, who belongs to the finance policy group. Every flow is inspected and enforced within the Zero Trust fabric, and the logs record which traffic matched, what decision was made, and why. For governance, the audit log records the policy change itself, who created it, and when. So in one workflow, you can see the embedded innovations, default deny, a segment of one baseline that limits lateral movement, and a single unified policy model that enforces identity, device, and application-based least privilege across the enterprise LAN, wired and wireless, without external overlays. In summary, Nile delivers a secure by default foundation, a segment of one approach, and simplified zero trust by unifying policies across wired and wireless without the need for complex NAC overlays or VLANs.